Alright, so in this tutorial, I want to explain how Specular works because I don't think a whole lot of level creators understand really how Specular works. They just play with it until they get kind of what they want. So here's an attempt at explaining how it actually works in the real world so you can better understand what you are changing when you change different parts of the specular color. To explain how specular works in the real world, I made this diagram. It's essentially taking whatever light source you have and the specular point, the points where you see the specular are the points where light beams reflect off of the object and directly into your eyes. This is basically how that happens. So you would see the specular here because the light ray bounces off at this point. This is different than how you would see the regular color of the object because this is light that is just bounced off completely. It does not take the color of the object, or you don't see, this isn't the object's color, this is the light's color because it's just bouncing, if this makes sense. You can see this on this object. The sun, not very visible right now. There. As you can see, the sun is right here. This point is the point at which the light ray from the sun bounce off of the object and into the camera. That's what this specular is. This is the specular, if you weren't already aware. Now, that's the basics of how specular works. However, there's a little bit to go over as far as how specular works in the material way in the game. So you got a few different properties. You got the brightness, the hue, the alpha, and something to note also, the alpha of the base color has an effect. So I'll go over these. The lightness or darkness essentially affects the intensity of the specular, and so does this. They both affect the intensity. However, this is a multiplier, so it multiplies the specular intensity it would have normally by the alpha value. If you want maximum specular intensity, you'd put this at maximum and this at maximum. If you want minimum, you would get nothing. But this is how these both affect intensity. Now for hue, it's pretty self-explanatory. It changes the hue of the specular, the color. Now, perhaps the most importantly is the alpha value of the specular color. Now the alpha value, how it works is the lower the alpha value is, the more spread out the specular will be. Now this is to emulate how specular works in real life. In real life, the smoother the object, the more the specular will appear like this. The more rough an object it is, the more the specular will appear like this. This can be seen as like a plastic toy. A very smooth plastic toy will have a specular that looks like this about. However, something more rough, such as a rock, any rock, will have a specular more like this. Now you might be saying, wait, my rocks don't look like this. Well, that's because normally the base color of the rock is so much darker and the specular color is much less intense. They would look more like this. The intensity kind of makes it look odd, but it is accurate. However, if you have water, if you ever put water on a rock, you might observe it gets darker. This is because the specular goes from here to here, because as you put the water on a rock, the surface of the rock becomes smoother. This means that it would go from this, which is to emulate how specular works on a rough object, to somewhere around here, which emulates how it would work on a smooth object. Now, as you can see, it turns from lighter to darker. This is what you see when you make a dry rock wet. It gets very visibly darker, and this is why. So that's the main thing about specular I don't see a whole lot of people doing. What I see a whole lot is they play with this, and they don't really understand that rougher objects should often have more lower alpha values. In fact, if it's a rock, it probably should be alpha should be 0 or near 0 if you are in fact trying to replicate how it works in real life. For metals that are kind of rough, you'd find some way in between. It takes a bit of testing to figure out where certain things should be, but essentially the smoother you want your object to appear, the more you want your specular alpha value to be high. If you want to imply that it's a rough surface, you want it to be low. That's the basics of the specular alpha value. Now, there's one more thing that I would like to talk about with specular, and that is the difference between what is called metals and non-metals. So, non-metals have a specular like this. Every non-metal that exists has a specular color that is white, like this. It's just a shade of white, not green like this. Yes. No matter what non-metal, it'll appear white. This is just how reality works. However, metals are different. With metals, the specular color will be the same color as the object. So I'm just going to quick copy the color of the object here, make it brighter. And this is how the specular would be if it was a metal. As you can see, it's more metallic looking. Probably make it even more metallic looking if you got the alpha value just right for whatever metal you wanted. This is mostly how you would make surfaces look much more metallic. Gold especially follows this trend. You'd have a yellow color and a yellow specular. But metals are the only realistic time that you would want to change the specular color, aside from some specific circumstances which you may learn about whenever you come across them. Whenever I see an object that doesn't really fit in with its environment, it's often because its specular color is off. If you have something like a decoration that you feel like should fit into whatever environment you're putting it in, but it doesn't, I suggest playing with specular first, because I've found that specular can really change how much an object fits in with its surroundings. Yeah, and that's about it with specular. I just wanted to go over this because I've seen many people try to do rocks that are just super smooth, like this. This is not how rocks work in reality, and it's fine to not do that, but it's good to know how it works in reality so you can know when to deviate, if this makes sense.